Okay, hello cats and kittens. It is Dr. Smith here with these long overdue solutions or answers to this Forces Conceptual Thinking worksheet. So, without further ado, let's get started here. So, problem 1 has a student standing on an ordinary bathroom scale inside an elevator, which accelerate upward, draw diagrams for both the student and the scale. So, remember for this, you're supposed to just draw the raw free body diagram and then show the coordinate axes you'd use. So for the student, let's see. First of all, the student has his weight. Okay, that is always mg. Student's mass, of course. Then you have the normal force and the scale on the student. So I'm going to label that n ss, and I'm going to call that. Actually, you know what? Pardon me for changing, but I'm going to say the student is 1 and the scale is 2. So I'm going to give numbers to my things. And I'm going to say this is the normal force that 2 exerts on 1. Okay, so 1 is the student. Okay, and those are the only 2 forces acting on the student. There's no other force acting on him. So if we want to break that down, we just want to do a vertical, could be y. You could put your x vertical, who cares? All right, and then object 2, which is the scale. Now the scale, of course, has its own weight, and that's going to be m times g. And to be clear, when we're talking about the student's weight and then talking about the scale's weight, let's make this one m1g and the scale m2g. Okay, that's legible. Okay, just barely. So, sorry, I had to move the computer there a little. So then what else does the scale feel? Well, the scale feels a normal force from the elevator, right? So I'm going to say this is normal force from the elevator acting on the scale. Okay, scale is number 2. And then it also feels a normal force from the student because the student's touching it and the student is pushing down on the scale. The student's feet are pushing down the scale just as the scale is pushing up on the student's feet. That is a consequence of Newton's third law. So normal force of 1 on 2. And in fact, we know that n21 and n12 have the same magnitude. And then we can also use the same axes for this thing. So that was all that you really were supposed to do. What you can do here is, if you want to, is you can solve the problem. So we do sum of forces equals, for the student, is m1a. If you don't want to see the problem solved, just move on. That's fine. So in the x direction, we have nothing equals m1ax equals nothing. Okay. And in the y direction, we have the normal force in the scale on the student. That is n21. I'm just going to write 2-1 instead of the 2 arrow 1. Okay, minus, but it's the same as this. It's the magnitude of this. Okay, minus the student's mass equals student's, or sorry, minus student's mass times g equals student's mass times acceleration in the y direction. Okay, and then for the scale, I don't put the arrow there. Okay, sum of forces is m2a, of course. And we have no horizontal forces, so that's your x direction thing, is m2ax, and that's 0. And then in the y direction, we have normal force from the elevator on 2, okay, going up, minus normal force that 1 exerts on 2. And the magnitude of this, remember, is the same as this guy, so I'm just going to go n21 there. I probably should have done the breakdown, you know what? So let me do the breakdown, FBD. Okay, N21, and this is M1G, and then here we have NE2 going up, and then you have M2G going down, and making our dot bigger. We have N21 again. That's a 2. I'll make it a little bigger. 2, 1. There we go. So now going back to our equation that we're in the middle of when I stopped. So NE2 up minus N21 down minus M2G equals M2AY. And so if we want to solve this, the thing is that the scale and the student are both have the same acceleration, which is the acceleration of the elevator. So in fact, well, and then the question is, what do you want to solve for, right? So probably the easiest thing to do here, or the most interesting thing, is what is the force the student exerts on the scale and the force the scale exerts on the student. Because what the scale measures, if you think about it, the scale doesn't measure your weight. It can't. It doesn't feel your weight. The scale measures the normal force that you are exerting on it, okay, or the normal force that it has to exert on you. So this thing here, the N21, is actually what the scale is reading. So if you want to see what the scale is going to read, N21 equals, and just take this one here. I mean, we're given A, right? The elevator is accelerating upward with acceleration of A. So that's going to equal M1 times G plus A. Okay? And so this A here is that AY. A equals AY. Okay? So this is what the scale is going to read in newtons. Now, if the scale will divide it by 9.81 to convert it to kilograms, so the scale reading in kilograms, you might say the scale reading in kilograms is going to be this normal force divided by G, okay, which is going to be M1 over G times G plus A. Okay, and then that's just going to become M1 times 1 plus A over G. So what you can see here is the scale will tell you if you're accelerating upward